So now let's talk about what we're doing in terms of integrating SWM now. And so what is SWM? SWM is the stormwater management model. It was developed by the EPA, and it's a dynamic rainfall runoff subsurface. And it claims to be continuous simulation. It's not going to do it as well as WWHM 2012. I'm just going to say that. So mostly relying on single event sources for that hydrologic data or for the hydrologic input. Most commonly what people do with something like EPA SWM, especially in this area, is we run WWHM 2012, we generate hydrographs and data based on that, and then we input that into EPA SWM to then get our hydraulic modeling results, which is just how we had to do it before now. Now you don't have to follow that elaborate process because that is not only tedious and difficult, inputting or exporting hydrograph data, scaling it appropriately, making sure that it lines up, making sure there's no data anomalies with the export, and then being able to run it. And then, as I sort of stated before, what if there's an adjustment now with your WWHM 2012 model that you have to make? Okay, now we got to re-export all the hydrographs again, put it back into EPA SWM and do it all over again. It's just, you're losing a lot of time if you're following that process. And so we wanted a solution for that. And so, like I said, EPA SWM mostly relying on those inaccurate single event hydrology, as I stated before. So not really useful from the hydrologic side. That's why we had to use HSPF and WWHM 2012, but we still needed SWM for the hydraulic processes. And so we're kind of stuck between a rock and a hard place, but now we're able to integrate it into one here. So to get the conceptual look at what's going on with WMSWM is SWM plus WWHM 2012 essentially is equaling WMSWM with very cohesive integration at that point. Also, if you have any questions, you can submit them in the chat and I can take a look at that. So if you have any questions so far, but we are actually going to get into the software too and take a look at what it looks like from the inside here. And so SWM was developed by the EPA. And so you're probably familiar with it. You've probably used it at some point, but this is what it looks like. And then you can learn more about it from the SWM 5.1 manual, which is you can find at epa.gov. And it's what I'm referencing for this presentation, essentially, because the SWM portion is highly based off EPA SWM, of course. That manual is 350 pages long. So you can either listen to me give you an overview for 10 minutes, or you can go read the 350-page manual. That's up to you. But definitely condensed what's available there for time and your personal ease at this point. The EPA stormwater management model is a dynamic rainfall runoff simulation model, and it's used for single event or long-term continuous. This is just from the excerpt before, not really doing continuous all that well. The runoff component of SWM operates on a collection of subcatchment areas that receive precipitation and generate runoff and pollutant loads, and that subcatchment element is included in WMSWM if you decided to do it that way. But in most cases, the land use basin can just be substituted and used quite efficiently. And so the modeling capabilities, SWM accounts for various hydrologic processes that produce runoff from urban areas. And so these include all of the following here: infiltration, percolation, but most importantly, SWM is good at the hydraulic functions of modeling. And so some of the typical applications of SWM since its inception, SWM has been used in thousands of sewers and stormwater studies, and this is really what we were getting at when we were doing the integration of WMSWM is its ability to do modeling these sewer and stormwater systems. And so design and sizing of drainage systems and some sizing of detention facilities, I guess, but design control strategies for minimizing combined sewer overflows, evaluating the impact of inflow and infiltration, generating non-point source pollution loadings for waste load studies, and then evaluating the effectiveness of BMPs for reducing wet weather pollutant loadings. So this is what the SWM elements look like in WMSWM. It's all the same ones that you're familiar with. They just got a little bit of a refurbished look, but you can tell which ones that we're using here. We've got the junction, we got the outfall, we got the divider, we got the storage unit here, the conduit pump, the orifice, the weir, and then that subcatchment element is also included as well in your program. So we really wanted to make it that if you just wanted to basically input SWM information and just run SWM, you can totally do it in WMSWM. If you just want to run WWHM 12, you can also do that. and you can import. And another thing I want to mention is if you have like an old WWHM 2012 project, a WDM file or something like that, it loads right up in WMSWM. So it's completely backwards compatible with anything you've done before. So if like you're working on a WWHM 2012 project today, it'll just load up in WMSWM immediately. And then you have access to all the amazing new features that we have added. You're able to export swim data pretty easily and then re-import that in we have quite a few different formats, and I'll look through when we get into the software all the different ways that we can import and export data. You can even export whatever the CAD, I think it's XML. AutoCAD exports XML files. I've done that before. I did a video on that where you can just export XML data, bam, add it to WMSWM, and it's there. So imagine like you had pipe data in AutoCAD, right? You're like, how am I ever going to get this into a way that I want to analyze? And then you had a WWHM 2012 project. You're like, these cannot work together. Well, actually they can. Load the WDM into WMSWM, export the land XML data from AutoCAD, and there you go. It's all in one project now, and you can model it all together. Pretty incredible, pretty groundbreaking, in my opinion, and it's going to expedite your modeling process quite a bit. And so the typical applications of SWM: designing and sizing of drainage system components for flood control, sizing detention facilities, and then mapping floodplains of natural channel systems. This is excerpts from the manual here. And so, like I said, really what we're looking at is the modeling of that hydraulic systems. And so here's a screenshot of EPA SWM, and then here's a screenshot of WMSWM. So we're combining the user interfaces of both to get something that's cohesive. And so you can see it takes a little bit from what EPA SWM looks. The modeling area is not gridded like WWHM 2012 is, where you're able to sort of snap things around in a grid. It's a little more freeform in that way, but still very organizable, very easy to use. And then if you're really stuck, you want to use the grid form, you can do that in 12, import it into WMSWM, and then you're done. And so we really want to combine some of the best aspects of both, and with very little adjustment coming from both. And so I always go back to this conceptual model here, combining HSPF and SWM. We have WWHM with HSPF, SWM with the output file, and WMSWM being able to marry those two together. And so WMSWM is able to utilize HSPF and SWM and the data there to do the computations, and then of course all the code that we've done in WMSWM is able to analyze that data, do additional calculations for you to calculate, flow duration standards, pipe modeling, etc. It goes on and on. The capabilities. I'm just really excited to show you. We're going to go into the software and take a look at what it can do. So that's an overview of what's continuous simulation, what's WWHM, what's SWM, what can it do for us, and then how are we combining these things? What are the elements? That's sort of the overview of this presentation. Now we're going to actually get into the software. So if you have any questions, I'm going to go back to I'm just going to go back to this real quick.